Okay, so this is actually, I think, one of the cooler types of problems you'll see in this topic. We can solve for gravity on other planets if we know very basic information. So first of all, 24,000 feet in 60 seconds. I forgot to highlight this blue, but maybe that's a little bit more representative of how you'll see it on tests. Not all these important words will be highlighted. So right here, we have a rover traveling to planet Z. We don't know the acceleration due to gravity of the planet, but we do know that the rover fell 24,000 feet. I skipped ahead because I saw numbers. But make sure you do read the problems first so you know what you're solving for. In 60 seconds, this is time. So I'm going to write down here, delta D is 24,000 feet. This is, time would be T is equal to 60 seconds. Even I have brain farts, guys. It happens. VI is equal to 0 meters per second because we have to assume that it fell that far. Whenever you see the word fell, just assume that VI is equal to 0 meters per second. Otherwise, it's impossible to solve unless we tell you what speed it was thrown at. So let's just start here. And quick question, do we know if acceleration is equal to 9.8 meters per second? No, right? Because we are on planet Z. It's different. So our unknown is our A. Sometimes you'll see a little g. Sometimes you'll see it written as just g. Is equal to question mark. And sometimes you might even see it as just A, like we've been doing for the rest of this PowerPoint so far. All right. My equation is the same as we've been doing the whole class. Plus 1/2 A T squared. Alrighty. So, let's plug this stuff in. 24,000 is equal to 0 times 60. Again, that will be equal to 0, so we can cross it out. Plus 1/2 A times 60 squared. So 60 squared, always do this first, is 3,600 divided by 2 is 1,800. So we have 24,000 is equal to 1,800 times A, because 60 times 60 is 3,600, divided by 2 gives us that 1,800. Then all we gotta do is divide both sides by 1,800, or 1,800, depending on how you want to say it. Then we have 24,000 divided by 1,800, and that gives us an answer of A is equal to 13.3. Since it's feet, it's got to be feet per second squared. Okay? That is our acceleration for this problem. Technically, if we were to say that we fell 24,000 feet, this should be negative, therefore making this negative, meaning this is a negative acceleration. But if you get the number right, you will not get the problem wrong. Okay? That will be given full credit as long as you get the number. So planet Z's acceleration due to gravity is negative 13.3 feet per second. All right? Now you just got a DOL to do, and that's it.